Hi, this is King of Review. Find an equation for the nth term of the geometric sequence 2, 2 square root 2, 4, 4 square root 2, and the sequence continues. So we have here something called a geometric sequence. A geometric sequence is a sequence or list of numbers or terms where the ratio of any term to the previous term is constant. So each of these numbers here is a different term. The first term, which is 2, this is called A1 because it's the first term. 2 square root 2, this is the second term, so we call it A2. 4 is the third term, so we call it A3. And this naming pattern continues. A4 is the fourth term. So let's look at how we go from the first term to the second term. How do we go from a 2 to a 2 square root 2? Well, we can multiply by square root of 2. And how do you go from the second term to the third term? In other words, how do you go from 2 square root 2 to 4? Well, you can multiply by square root of 2. Do you see a pattern here? How do we go from 4 to 4 square root 2? Again, we multiply by square root of 2. And if we wanted to figure out the next term, we'd multiply by the square root of 2. So you can see this pattern. We get to the next term by multiplying the previous term by square root of 2. So square root of 2 is the common ratio. That's what this ratio is called. We can also calculate the common ratio using this equation. R equals A2 over A1. Let's put these values in. A2 is 2 square root 2, and A1 is 2. So we have 2 square root 2 divided by 2. These 2's cancel out, and we're left with the square root of 2. So this is the common ratio of this geometric sequence. Now I chose A2 and A1, but you can compare other terms as well. Let's look at A4 compared with its previous term, which is A3. So whichever term you pick for the numerator, you must compare that term's previous term for the denominator. So A4, which is right here, this is 4 square root 2, and A3, here, that's a 4. The 4's cancel out, and we're left with square root 2. You see we're getting the same numbers here for the common ratio. In this problem, we're asked to find an equation for the nth term of this sequence. So we have a rule for a geometric sequence. This rule has the following formula. An equals A1 times R to the n minus 1 power. So this is the nth term of a geometric sequence with A1 as the first term and R as the common ratio. So we'll use this formula here to come up with our equation. So we have An equals A1, that's this term here, which is a 2 times R. We've already calculated R, the common ratio. That's square root of 2. So I have square root of 2 to the n minus 1 power. Now let's simplify this. If we have the square root of x, we can write this as x to the 1/2 power. So let's write square root of 2 in this manner. An equals 2 times 2 to the 1/2 power, and this is raised to the n minus 1 power. Now we have this exponent here, and this number, this entire number, is raised to this power. So let's distribute this 1/2 to both of these terms. We have An equals 2 times 2 to the 1/2 n minus 1/2. And now how can we write this 2 here with an exponent? If we have x to the first power, this is the same thing as x. Or if we had 50 to the first power, this is the same thing as 50. Any number to the first power is that number. So to write 2 with a power, we would write 2 to the first power. And now we need to consider the following property. If we're multiplying two numbers that have the same base, we can add their exponents together. So if we have x to the a times x to the b, this equals x to the a plus b. Now you see here we have a base of 2 times a number that also has a base of 2. So now we can combine the exponents by adding them. So we have an equals 2 to the 1 plus 1/2 n minus 1/2. And now let's simplify the exponent. We have an equals 2 to the 1/2 n plus 1/2. And this is our final simplified rule for the nth term for this geometric sequence here. So letter B is correct. One way to check if you got the right answer is to plug in some values into the equation that you came up with. So let's take this term here. Let's take the third term. A3 is 4. So the third term, which is A3, this is 4. Let's plug this in to our equation for the nth term and see if it makes sense. So A3 equals 2 to the 1/2 times n, this is the third term, plus 1/2. And we're trying to see if this is equal to 4 or not, because we know that the third term should equal 4. So let's solve. So we have 2 to the 3/2 plus 1/2, and this equals 2 squared, which equals 4. So we're getting 4 for the answer here. So we know that this equation was set up properly. Thanks for watching.